आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you all a podcast series on STEM popularization. That is, science, technology, engineering, mathematics, and medicine. Supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation. Creative content and technical support is given by Farzeen Sultan.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
आज का टाइम टेक्नोलॉजी का टाइम है और इस टेक्नोलॉजिकल दुनिया में मशीन्स हमारे रोजमर्रा के काम में बहुत मदद करती हैं। अब सवाल आता है कि जो मशीन काम करती हैं वो कैसे करती है, और इसका जवाब है मशीन कंट्रोल सिस्टम। ये सिस्टम एक ऐसी टेक्नोलॉजी है जो मशीन्स और डिवाइस के मूवमेंट को प्रिसाइसली कंट्रोल करती है। ये सब मोशन कंट्रोल सिस्टम की वजह से होता है। ये सिस्टम एक सेट ऑफ डिवाइसेस का कॉम्बिनेशन होता है जो मोशन को रेगुलेट करता है, जैसे मोटर्स, सेंसर्स, ड्राइवर्स और कंट्रोलर्स। इनका काम होता है कि किसी भी डिवाइस के मूवमेंट को एक्यूरेट और एफिशिएंट तरीके से मैनेज करना। आज के टाइम में मोशन कंट्रोल सिस्टम हर जगह यूज हो रहा है, चाहे वो इंडस्ट्रियल मैन्युफैक्चरिंग हो, रोबोटिक्स, एयरस्पेस, एग्रीकल्चर या मेडिकल फील्ड। मोशन कंट्रोल सिस्टम का एक और मेजर फीचर है फीडबैक लूप, जो सिस्टम को अपनी पोजीशन और मोशन को कंटिन्यूअसली मॉनिटर करके नेसेसरी एडजस्टमेंट्स करता है। इस तरह से हर एक मूवमेंट कंट्रोल्ड और एक्यूरेट होता है। इसका यूज हमेशा क्रिटिकल एप्लीकेशन में होता है जहां प्रिसिशन और एफिशिएंसी बहुत जरूरी है, जैसे कि रोबोटिक्स, सीएनसी मशीन और ऑटोमेटेड असेंबली लाइन। और इस पर काम कर रहे हैं एरीज, आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में साइंटिस्ट एफ के पद पर कार्यरत डॉक्टर टीएस कुमार।
सबसे पहले जानेंगे एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में इंजीनियर एफ के पद पर कार्यरत टीएस कुमार के बारे में।
Hello, I'm T.S. Kumar. I'm from Aryabhatta Research Institute. I am actually a electronics engineer here, engineer F by designation. I did my BTech in electronics, and then I did my PhD in systems and control from IIT Bombay. So I mainly work in the field of control system and electronics, focused on telescopes, ground-based telescopes here, because we have many telescopes at ARIES. Roughly this is my background, and I work on aspects of motion control system for telescopes, for example, to control the velocity and position very precisely, to precise imaging of these celestial objects. Then I develop imaging cameras which can precisely image the celestial sources, which are low noise cameras based on CCDs. And currently I am also leading space situational awareness work at ARIES, where we have collaborated with several agencies. For example, we are building one observatory for ISRO, which will be jointly used by ARIES and ISRO for both astronomy and space situational awareness.
अब जानेंगे सर का रिसर्च एरिया क्या है।
To put this into simple language, we call it control system. That means to control anything. For example, we have air conditions or fan. The speed is controlled. We use a regulator to control the speed of fan. We use a remote control for controlling the temperature of AC. So for telescopes, we have to control the speed of the telescope. That is, it has a motor just like your fan or a electric vehicle. The speed of the motor has to be controlled so that telescope is very precisely tracking the objects, moving continuously and tracking the objects. So this control system is one domain of engineering where we actually understand how the system behaves, try to capture the physical parameters, the physical behavior of the system, and describe using some mathematics, some formulae. So once you have this formulae, you can easily put it in a computer and simulate it. So you have a digital clone of a system. So once you have everything on the system, you can sit back, relax, and start working on the system, develop digital controllers. And once you are satisfied, you can again get back to the physical world and build the real systems. So that's what we do in the domain of control system. That is to control anything. For example, to control temperature. Even in farming sector, it's used for monitoring the soil humidity and temperature and controlling the irrigation, etc. So anything which has to be controlled, it can be done using control systems.
सर का ये रिसर्च भारत के लिए और कॉमन मैन और स्टेम के लिए कैसे यूज़फुल है, आइए जानते हैं.
Yeah, so I'll start with our country. To begin with, we see that now the industrialization is in a boom now. The industries are coming from, there are many industries which have come up, large industries, and they all look for automation to improve the productivity, quality, and quantity. So this control system is widely very much used in the field of robotics to control the industrial robots, to control the process. For example, the drug industries, chemical industries, we have to precisely control the ratio of the chemicals. So this control system is used there as well. When I talk about telescope, we bought this telescope, to be frank, because all these telescope as a system are imported, but then we upgrade using our indigenous technology. So when we say controlling the motor of a telescope, same technology can be used to control an EV, electric vehicle. Nowadays, it's a big thing. Same technology can be used to control the robots. The imaging systems which we use in telescope, precise imaging, now it is used in ADAS of vehicle to, automated driver assistance system. Also for machine vision, where the process is controlled using vision cameras, high-speed cameras. In medical field, now endoscopy and all using high-resolution cameras, they operate. So these cameras are widely used in all these fields. So whatever we are developing, they are very precise and they can be easily adapted for industries and these applications. Also for defense surveillance. Nighttime photography can be used for night vision systems. Infrared cameras which we use can be used for food industries, for grading, for rejecting the bad quality products, and for detecting the adulteration, etc. These are, and for humankind, I will say that our country GDP is dependent on industries, services, agriculture. So farming sector, if you see, this again can be widely used. For example, automated farming, like automated sowing system. Nowadays, you have heard of automated tractors, and greenhouse control, where you can grow anything throughout the season by controlling the environment of the greenhouse. Irrigation system, livestock monitoring. These can be directly applied in this area also. So of course, so that's how it is useful for the country as well as the humankind.
अब जानेंगे सर की पास्ट, प्रेजेंट और फ्यूचर रिसर्चेस के बारे में.
My past research area had been very broad. As I said, I also worked a couple of years in Tata Motors, so I have experience in automation. So that I wanted to apply for telescopes here, the instruments which we use on telescope. And slowly, once you work on large systems, you become more versatile. So more ideas come, you learn many things. Now, in the past, I've used control system and electronics to just upgrade and maintain the systems, maintain the telescope, upgrade them. Now I'm using it for not only for telescopes, but the idea is to develop a versatile generic motion controllers, because most of the controllers we import, they are very, very expensive. They are used in CNC controllers, they are used for robots. They're all imported. Countries like Japan, Germany, and US, they make such controllers. Now, the idea is to develop a versatile controller which can be used for telescope, and it can be adapted for industries also. When I say modular, modular means you buy a controller for sufficing the current needs, and you, as your requirements grow, you buy more modules and keep adding to the controller. So it's modular. You can keep expanding or shrinking the size. And when I say generic, it can be used for many applications. Telescope is one which is useful for us, but of course for industries, robots, also for electric vehicles, the same controllers can be used. We have developed motor controllers, drives, which again can be used for these applications. So yeah, so this is what we are thinking to have to reduce the dependency on the Western world, because it's very expensive, which can be easily developed in country. And imaging systems, as I said, in automation, India ranks, I think, 7th in the global scenario, but now we are climbing the ladder. But in the imaging systems, we are still much behind. So if we can develop a generic imaging controller like CMOS imagers, high-speed imagers, which can be used for various applications, not only for telescope, but for medical field, for surveillance, for machine vision, for ADAS in vehicles, that will be really good. So we are working on such system using FPGAs. We are developing the CMOS and CCD image controller.
सर की ये रिसर्च ग्लोबली कहाँ स्टैंड करती है, आइए जानते हैं.
Astronomers you have interacted, they might have told in global scenario what is our standing. But engineering, India is doing very good, both in software and the hardware. But most of the people, they leave and they work in MNCs. But yes, in automation, our ranking is about 7th, I guess, because the countries like the Koreans, Japanese, and German and Americans, they use a lot of automation, so they are occupying the top tier positions, but we are of course catching up with them. In development of instrumentation for astronomy, our there are contemporaries like IUCA, IAEA, ISRO is one. So there are many government agencies which are working in this area, but there are competitors worldwide also, like ESO is there, European Southern Observatory, then NOAO, American agency, a consortium which works on astronomy. Then of course, I said space situational awareness. Now lot of data has been generated by European and American agencies for space using ground-based facilities. This has not been done in country. So in SSA, we are trying to set up ground-based stations to monitor all the man-made orbiting objects in space. For example, satellites, the space junk, what we call space debris also. So we are trying to monitor them so that we know in future missions. Of course, ISRO is funding this, and they want to use this so that they know the exact safe window when to make the critical launch. So that is one area. Right now, we have to buy this data from this Western world, but once we have this set up here, then it will be very useful.
इंडियन इंडस्ट्रीज इस रिसर्च से कैसे एसोसिएटेड हैं, आइए अब इसके बारे में जानते हैं.
Yeah, many industries, of course, most of our suppliers are now based in India, and we are also buying some subcomponents and subsystems from them. And this SSA telescope, which we want to use for this space surveillance of the orbiting objects, the entire telescope was developed by Indian industry in Bangalore. And the motion controller for the mount also we are planning to develop using Indian support, both hardware as well as software, and also the embedded system and embedded firmware that will be developed using the Indian partners, Indian industries. Yeah. So we have a lot of capability. Of course, their focus is different, but when we discuss with them, there are many common elements which can be jointly developed. But of course, we have to train them in the field of astronomy. They have to train us in the field of industrial trend these days. So yeah, this has been successful, and we are now we have lot of industry partners who are, even this 3.6 meter telescope, most of the spares has been procured by within country.
अंत में क्या संदेश दिया टीएस कुमार किप ने, आइए ये सुनते हैं.
This is very good initiative and very important it's an essential thing, because unless we connect with people, ideas always come when we discuss with people, with the community, and there is a lot of potential in amongst the Indian youngsters, the engineers, and many people. So unless they know what we are doing, and unless we know what potential is there, it's not possible to develop a system. It's not possible to put dreams into the actual system. So it's very important, and this also helps us in sharing knowledge with each other. For example, what there are many institutes, and it's very difficult to connect with all of them. There are many people, everyone is busy nowadays. So if we have a platform where all this knowledge and this is put in a one place, and this forms a very good network. For example, like I said, SSA, when we started networking with ISRO and things become popular, other agencies like now DRDO, they want to join. With BEL, of course, we had an MOU recently. So there's a lot of interest, and many things can be done within country. We have huge population and a lot of young talent. So thank you very much for giving me the opportunity to express my views on this matter.
तो अभी आपने सुना हमारा ये खास कार्यक्रम। आशा करती हूँ आपको आज का ये कार्यक्रम पसंद आया होगा। अब हमें दीजिए अनुमति। नमस्कार।